Am I audible?
Yes, sir, audible.
Okay, fine. Yeah. Hope all of you are able to see my screen.
Yes, sir.
Okay, thank you.
Yes.
So we are discussing about different type of bulbs, in the last class, and we'll continue with that. The last which I discussed was check bulb or reflux bulb, and the next one which we are going to talk about is basically air bulbs. So air bulbs are called as automatic bulbs, and they are two types mainly based on their function. So one is air inlet bulbs, another one is air relief bulbs. So in most of the time in water distribution scheme, the requirement of air relief bulbs is more compared to air inlet valves. So I'll give you a brief idea about air inlet valves. So these valves open automatically and allow air to enter into the pipeline so that the development of negative pressure cannot be uh, cannot happen within the pipelines. Fine. So the vacuum pressure created in the downstream side in the pipelines due to sudden closure of sluice valves, this kind of situation can be avoided by the using of inlet valves. Now the another one is air relief valves. So that is what actually we are going to discuss in detail. So we have a schematic diagram in the next page. So this is the air inlet valve. So let me first discuss about this, and then I'll uh, explain the schematic diagram. Sometimes air is accumulated at the summit of the pipelines and blocks the flow of the water due to air lock. So this particular phenomena you might have or experienced during summer days in your own tap water service. Like if there is a sudden there is a stop in the water flow, and after a certain point of time, even if your tank is full, water is not coming in the tap. So this happens because of the air choking or the air lock into the water pipeline. So in such cases, the accumulated air has to be removed from the pipelines, and this is done automatically by means of air relay valve. Since in the beginning we have mentioned one thing, that any type of air valves are automatic, so we need not to have any extra manpower to operate this particular type of valves. Rather, they will be operated by themselves, and that is why you call them as automatic pump, automatic valve. So this valve consists of a chamber in which one or two floats are placed and is connected to the pipeline. Fine. So you can see here we have the floats. That is what actually I just mentioned. So one or two floats will be kept in the water, and then the floats will be connected to a pipes. Fine. Now what happens is, when there is a flow under pressure in the pipeline, water occupies the float chamber and makes the float to close the outlet. Fine. On the other hand, what happens when the water is not there or water is not flowing? Then during that time, and that can only happen when the water in the flow is flow pipe water in the pipeline is not flowing. During that time only you can have such kind of situation. So where there is accumulation of air in the pipeline, air enters the chamber and makes the float to come down, thus opening the outlet, and the accumulated air is driven out through the outlet. What happens is, once you have the water flowing in the pipeline, so it is flowing under pressure, so it will exert some pressure in the top tank, and this tank, if the level of this float is higher, and this is a there is a counterweight, and there will be a lever action, and because of that, this particular connector rod will come down and ensures that the this outlet is closed. Whereas when there is no water supply and there is a chance of air getting creating lock in this particular area, so that time what will happen is this float will come down and then it will push up this connector rod. It will go up and it will create this outlet valve to open, and through that passage the entrapped air will get released. And this is the way, and this particular mechanism happens automatically, and that is why we say air relief valves are automatic. Fine. Now these are also called as wash out valves, and they are provided at all dead ends and
Sir, you are not audible actually. Hello.
Sir is not in the meeting. Or
Am I audible? Hello.
Yes, sir. Now audible.
Okay, so which one was the last you could hear? Which was the last slide you could hear when I was discussing?
Sir, you are showing the diagram of air valves. Sir.
Oh, only air valves you could hear. Okay, so pressure relief valves you could not hear, right?
Yes, sir.
No, sir.
Okay, so you should have called me immediately. Anyway, so air valves, could you understand air valves completely? So I discussed, I explained the working principle and mechanism of air valves. So I hope you could hear that.
Sir, please explain again once.
Okay, so basically what happens is air valves, what we are actually showing here is the air relief valves. So the main idea is the air which gets interrupted because of the discontinuation in the flow need to be, you know, take it out from the main pipelines. That is the main objective. So what happens is during the flow under pressure, so there is a tank which is attached. So within tank, basically the air relief valves will be kept or placed. Now, once you are actually flowing water, so it is under pressure, so it will because of that pressure, the water will come to some level within the tank, and then it will help the float to go up or move up, and then because of the lever action, as it is drawn over here, there is a counterweight on the other part. So what will happen is this connector rod, you can see this connector rod, will go up, and it will actually close the air inlet or or outlet valve, so the water will not be able to move through that valve during the flow. On the other hand, when you have discontinuation or less pressure in the flow, or or there is a discontinuation in the flow, so what will happen is air will get interrupted within the system, and because of that, what will happen is the water which is actually stored in the upper tank will come down in the pipelines, main pipelines, and then at the same time the float will also come down. As a result, the connector rod, this particular rod, because of the lever action, will again come down, and then it will open this air inlet and outlet valves. Now once this is opened, so the extra interrupted air will pass through and so there will not be any air lock when there is a next flow period. So that is the way air relief valves works, and it actually help in maintaining uninterrupted flow during the period of you know flow of fresh water in the, or in case of maybe intermittent supply, during that time, during the time of flow, we get interrupted water because of these air valves. Is that clear now? So now I can move ahead.
Yes, sir.
Yes, sir.
Okay, very good. So the next one which we are going to talk about is pressure relief valves. Now, from the name itself, you should be able to understand what actually we are going to talk about here. Now, pressure relief valves are actually attached in the main pipelines to reduce down the pressure. Now, before that, we need to understand when and we should actually think of such kind of valves and why it is required. Now, what happens is there are some location in the pipelines where the pressure can be maximum during the flow period, and if it actually goes beyond the maximum allowable pressure within that pipe, then there is a requirement to reduce down or to cut down that particular pressure to the permissible limit. And the same thing can be conducted with the help of pressure relief valves. Now, how these pressure relief valves are operated? So let me explain you this. So we have a spring operated arm or valve, which is the main part and which acts as a valve here, and that is attached to the main pipelines. And during the flow, so the flow will be under pressure, and then in the right hand side you will have the sluice gate. And what happens is sometime the flow, so suppose this is the point where we are expecting to get the maximum pressure, and that is the reason we have attached such a pressure relief valve. Now, once there is a flow, so the pressure will be developed, and after a certain point of time, once this pressure is going to be more than the setup pressure or preset maximum pressure, then what will happen is the spring will actually, because of the extra pressure, the spring will squeeze, fine, and then this particular attachment will go up, thereby creating space through this two end. So in 360-degree there will be a space, and through which this extra water will flow, and then it will flow through the relief vent, thereby creating or reducing down the pressure within the permissible limit. So this is the way pressure relief valve works while it is attached with the main pipelines. Now, there are two different type of valves which we will be talking about. One is altitude valves, another one is cover valves. Now, so before going into cover valves, let me talk about this altitude valves. Now, there are 2 points I have mentioned over here. Among them, the second point is very important. So in the first point, I am just telling here that in which are the situation where you need to think of altitude valves. So mostly for the elevated tanks and or the stand pipes. These are the two components before which we actually attach the altitude valves. But the reason why these altitude valves are required, so they close automatically when the tank is full, that is number one, and open when the pressure on the pump side is less than that on the tank side of the valve. Fine. When the pressure on the pump side is less than that on the tank side of the valve. So that is the way it helps in maintaining uninterrupted water supply, because it ensures no loss of water or wastage of water, because it will automatically close once the tank is full. And at the same time, if the tank is not full, then the pump, it will get opened, and then the water which is coming from the pump will go and get stored in the tank. So this is the main function of altitude valves. And now we'll be talking about scour valves. So from the name itself, you are able to understand that scouring can happen within the pipelines itself, and that is the reason we need to get rid of from those elements which can create this scouring or which can increase the chance of scouring. So scour valves or blow off valves or washout valves are ordinary sluice valves that are located either at the dead end or at the lowest points in the mains. Now they are operated to blow off or remove the sand or silt deposit in the pipelines, thereby reducing the chance of scouring. Fine. And this particular type of valve is operated manually. So this is not an automatic valve which we discussed in the previous cases. Fine. Next is so with this we are actually finished completing the different type of valves. Now I'll be talking about two most important appurtenances, that is water meter and fire hydrants. So water meters, these are the devices which are installed on the pipes to measure the quantity of water flowing at a particular point along the pipe. So it basically gives us an idea about the total consumption of water through that particular point. Now the readings obtained from the meters help in working out the quantity of water supplied, and thus the consumers can be charged accordingly. So this water meter gives us the flexibility to charge differently in different consumption point within the same water supply network. The water meters are usually installed to supply water to the industries, hotels, big institutions, etc. Metering prevents the wastage of purified water. So the psychology is, if there is a metered water connection, people will reduce wastage of purified water. Now there are few I'll discuss about the requirements of a good water meter. So just here, or if you want to make points, you can make in your own copy. So once we say a good water meter, so a good water meter should have the several characteristic features which I am going to point out. So capable of measuring all kinds of flow. So it should be able to measure all kinds of flow, throughout the day, throughout the year, basically for the entire service life. Now it should be economically viable, and at the same time the error in the water meter should not be greater than 20%. Then unnecessarily you will end up charging more or charging less. So in any way it is not beneficial for the beneficiaries associated with the water supply scheme. Now water meters should be able to withstand all kind of pressure, and when we attach water meter there is a chance of head loss. However, you need to ensure that the water meters, or a good water meter, should have less or minimum head loss during its time of operation. Now if they should be chemically susceptible, that means if there are chemicals present in the water, that should not affect the performance or the efficacy of that water meters. And you need to good water meters should have that capacity so that no backflow takes place, and it should be free from all sorts of clogging. So these are the different good, or maybe salient features of good water meter, we can say. And these are the points which needs to be considered before procuring water meters, because this water meters is going to be delivered or attached in the water supply system by the authority itself, and that is why it actually influences the overall cost of the project to some extent. and that is why it is very, very important, and it needs to be considered with analyzing all the other factors which I have discussed. Now the next part is basically fire hydrant. So we are going to talk about fire hydrants. So first let us try to understand what is fire hydrants. So basically a fire hydrant is an outlet provided in the water pipe for tapping water, mainly in case of fire accident. So in main pipelines, these fire hydrants are located at 100 to 150 meter apart along the roads, and also at the junction of the roads. And if you see, these fire hydrants are basically two types: flash hydrants and post hydrants. So before going into that flash hydrants and post hydrants, let me talk about a good fire hydrant. I mean, when we say good, what sort of characteristic it should have? So basically, fire hydrants should have the following characteristics, which have been mentioned in the bottom of the slide. You can check them. So it should be economically, less expensive, because that would significantly affect the overall cost of construction or cost of project. It should be easily connectable to the hose or the motor pump, which during the fire accidents would be operated. It should be easily detectable during the emergency. So it has to be, most of the time, if you might have seen that it is fire hydrants are actually painted in red color, so that during the time of emergency it is easily visible. Now these type of fire hydrants should be absolutely reliable. It should not get any fault when it is required to work. Like fire hydrants are the appurtenances which will not be operated throughout the year. Maybe during the service life it may be utilized once or twice, depending upon if there is a fire in the vicinity of that fire hydrants or not. That is why it should be absolutely reliable, so that you can rely upon them. And if there is a need, it should work without any failure. And thus another one important thing is it should be able to draw a huge quantity of water, and in uninterrupted way or in undisturbed water flow should be yielded from a good fire hydrant. So these are the characteristic features of a good fire hydrant, or in other words we can say these are the requirements of a good fire hydrants. Now let us talk about the types of fire hydrants, which I have already mentioned. So basically these are two types: flash hydrants and post hydrants. So the flash hydrants is kept in underground chamber, plus with the footpath covered with CI cover, carrying a signboard FH. So you might have seen some cap which is actually connected with the underground chamber, and that will be usually flushing with the footpath covered with the cast iron cover, and on the top of that you will be seeing that the signboard of FH, that means fire hydrant. On the other hand, post hydrant. Now post hydrant remain projected 60 to 90 centimeter, and conventionally we can see it through our eyes, from the from the uh, larger distance. And in the right hand side in my slide you can see the post hydrants. I have kept a photo of post hydrants. Again, it is painted in red color, and they are 60 to 90 centimeter long. They have a long stem with screw and nut to regulate the flow. In case of fire accident, the firefighting squad connect their hose directly to the hydrant and draw the water and spray it in the place of the fire. Fine. So now, apart from that, there are few other type of appurtenances which we are going to talk about now. So that is the detection of leakage, right? So how to detect the leakage is a big question, and if the overall generation of revenue of a particular water supply scheme depends upon how efficiently you as an engineer are going to detect the leakage of the water, purified water. So that is the reason, and at the same time, if you want to make your engineering and practices associated with water supply sustainable, the leakage should be absolutely minimum, and that is why the detection is very, very important, or the prior, most prior importance, I would say. Now there are different ways by which we can detect the leak. So the first one is direct observation. So in case of direct observation, practical observation of wet spots on unpaved ground, or luxurious growth of grass in a lawn, or emergence of spring at an odd place, would suggest that there are some leakage in the main supply line, or main water supply line. These kind of occurrences are found when pipes are laid below loamy or clayey soil. So it depends. If there is a leakage, then if that is in the clay or loamy soil, so those kind of spring and all those things may happen. Next is, these observations are not suitable on sandy soil, obviously, because the permeability is much higher, and you won't be able to understand that the water is coming from the far away, or it is basically from the supply line. So you can conclude something if the native soil is loamy or clay soil. Fine. Next one is using sounding rods. So this is a more sophisticated method, I would say. So in this case, a sharp pointed metal rod is thrust into the ground and taken back. Fine. Presence of moist or muddy point will indicate the leakage. Escaping water sound is also heard using aquaphone or sonoscope instrument for magnified sound. So by this, so one is sounding rods, another one is aquaphone or the sonoscope. So these are the different devices would facilitate hearing the water sound which is escaping from the mainland in the form of leakage. Number three is plotting hydraulic gradient. So in this case, what is done is, we'll plot in x-axis we'll plot voltage, and in y-axis we'll plot current. Now pressure at different points in pipeline is measured, and hydraulic line is graphed. Now kink or change in slope of hydraulic gradient lines indicates the leak. And so basically what is measured is current and voltage, and that can be converted into the hydraulic parameters which we are talking about. And if there is a kink, or if there is a slope, or if there is a difference in the continuation, that means there is a chance of leakage. So this is the way also leakage can be detected. Apart from that, we have the waste detection meters. So this is also a very sophisticated device. These meters will measure an unusually high flow passing through the pipe mains during low consumption. So early morning or night, or maybe so from these you will be able to understand that there are something wrong which is going on, since the time is not conducive for high consumption. Still you are getting high consumption from the waste detection meters. That means that there are some leakage, or there are some wastage, or there are some unestimated water which is actually getting consumed. So from these different aspects, you should be come to a conclusion that some leak may happen in the supply main. Now test is conducted only at night for this, detection by the help of meters. The individual supply lines are tested to detect the leakage. So this is the different ways by which, detection, by which the leak can be detected in the main line or main supply line. So now we'll be discussing about storage of water in buildings, and before that, I want to tell you a few things that we have different fixtures and fittings of water supply scheme. You should go through, since it is not there in our present syllabus, so I have not included them here. However, all those things may come in the competitive exam, so you can go through them once to just to understand how things are and what is the purpose of them. So we have different type of fixtures, sink, basin, water closet, different type of tap, all those things. And on the other hand, we have fittings. So we have different type of joints, trap, T joints, even reducers, offset, 45-degree elbow, Y branch, 90-degree elbow. So these are the different type of fittings which are also used in case of distribution network. And we have different type of nipples, flash busing, pipe coupling, hexagonal bushing, so different reducing coupling. So different type of components are there, which I'm not discussing now. We'll go to the next part, so that is the storage of water in buildings. So basically, in the building, the storage of water is required for several purposes. For supplying the water to the consumers during non-supply hours. In most of the cases, still now in India, water supply is intermittent instead of continuous. For reducing the maximum rate of demand on the water mains. So that is another one philosophy of putting a storage in the buildings. And for storage of water during interruption or damage repair, or any sort of problem or discontinuation in the supply. So if there is a storage, then most of the time, if you see, like in our locality or municipality, if we have a storage tank, or maybe in the society or in the buildings or in the house where we live, if we have a storage tank, most of the time we don't realize when these water supply systems are being maintained by the municipality or by the authorities, because we basically store the water, and then once the storage is over, we get the water again. And maybe in the meantime, the maintenance work is done. So that is why, though there is a chance of interrupted supply. However, we are unable to understand that, since we have a storage attachment in the buildings. So this is another one purpose of putting them. And when the available head is insufficient to supply the water, in such cases, like in case of multi-story building, in those cases, if we have a storage in the building itself, it would be good, and we can still get the uninterrupted water in our tank. Fine. So the water storage capacity of buildings depends upon our hours of supply of the intermittent supply, rate of supply, like in what rate water is coming, and how much time it will take for a particular volume of tank to completely to completely fill. Demand pattern in that particular building, like which are the time period when the demand is high, so there will be a pattern of that, and then the higher storage requirement. So how much water should be stored in case of fire accident. So analyzing all these different points, that the storage capacity, and its storage capacity is calculated for a particular building. So with this, I'll stop today.